All right, now, let's keep going. Now, I'm going to leave this proportion one for a second. Let's have a look at the average, because I think it's not that hard in terms of proportions, okay? You're still going to be working out much the same thing. You're going to work out how much population has changed, okay? You're still going to be dividing by the total time that it took to get that change, okay? But to turn this into a percentage, right? Suppose I did tell you, all right, we gained 500 rabbits, and it took 5 years, okay? So that would tell you, all right, 100 rabbits per year. Okay? That is an absolute. I should have put that in this row, okay? That's an absolute rate. So how do I turn it into a proportional rate? What would you need to, what extra information do you need to know to give this as a proportion? What are proportions? You're like, I scored 80% in this test, which is a 10% improvement on my previous test. Okay, so that's a proportion. That 10%. That's a growth rate. Okay, so what information do you need to know to say, oh, I went up 10%? Yeah, wait. Sorry, say it again. The total. The what? Sorry? Oh, the total what? Okay, right. Now, I'm looking for a population number, right? But the question is, which population? The initial population, right? So when I said, okay, 100 rabbits per year, that could be like saying we double the number of rabbits we had, because they're growing like rabbits, okay? So that would be a 100% gain. If I started at 100 rabbits per year, right? But maybe I started at 1,000 rabbits per year, okay? So I'm going to be dividing by whatever this number is, okay? That number is that number, right? Your initial population. The population at time 1. Does that make sense? Now, I'm not writing these formulas for you to memorize. In fact, I would actively encourage you not to memorize them. But certainly you can see what's going on. Particularly so you can see the relationship between this one and gradient, it's just rise over run, and the relationship between this one and this one. You're just dividing by your initial population, or your initial mass, or whatever it is. Okay, now, let's, I'm going to leave this one to last because it's the weirdest one. Let's do this one, because it's actually very easy. If I want to know the instantaneous rate of change of my population as a function of time, okay, what is it? It's just my derivative, right? So in fact, it's the absolute without any specific time put in. Okay, that's why it's still a function of time. Okay, last one. Now, remember here, we said, I want the rate of change in proportion to that original population that I started with. Okay. Now, when we come over here, it's going to be in proportion to something else. It doesn't make much sense to say initial population, because here you don't have two different points in time, an initial one and an ending. All you've got is one point in time, right? Just one point in time. So if you're going to divide by that, what you want is this rate of change, dp on dt, okay. And you're going to want to divide by your population, right? P. Make sense? It's not P of T1. Well, I suppose we could call it P of T1. We just have one time, right? But it's not an initial time versus an end time, okay? But stop for a second. Look at this. Look at this really carefully, okay? You actually already know exactly what this is equal to. Actually, it doesn't really matter what we call it, because as you'll see in a second, this is irrespective of time. This is an exponential growth indicator, right? There's a relationship between dp and dt and p. What's the relationship between these two? It's the equation which every single question starts off with, first part. It says, prove that this equation fits this relationship. This, right? Isn't this equal to k? Right? You don't usually see it in this form. Usually you see it in this form, right? But it's the same equation, right? I've just moved a little bit to make the ratio obvious. Okay? So therefore, put the p back over there where I want it. Okay? When you want to know, and they'll actually say it in these terms, right? The instantaneous growth rate in proportion to your population at that time. All they're asking for is K. That's all they want. They just want, a better way to ask it would be, tell us the constant of proportionality. Because then it makes clear that what you're after is K, the constant, which as you can see, has nothing to do with time. Completely separate. Okay? But sometimes, and this is the really, really ultra frustratingly confusing part, okay? Sometimes they'll say, this thing here, the question will say, tell me the growth rate. Growth rate. And what they mean is, tell me K, right? So if you see growth rate on its own, no other explanation of what it is, they mean K. As opposed to, get this, the rate of growth when, ... Okay? So, okay, now, I used to get so frustrated about this, because I'm like, growth rate and rate of growth are the same thing, freaking English language, okay? But there are clues in there to help you understand what's going on. For instance, see growth rate, right? If they don't give you any information apart from that, then it must be something separate to time. Does that make sense? Because otherwise they'd have to tell you, well, what value of t do I want it for? Okay? But here they'll say rate of growth when, or in 1995, or when the population hits such and such an amount. So they're actually looking for a specific value at a specific time, t1. Okay? So if there's a time in here, right, you'll work out this, but there's nowhere to put that time into, so you know that's not the answer they're after. Okay? Actually, you just want to differentiate and stick the time.